arc length in polar coordinates. We're interested in the length of the curve r equals f of theta, where theta is between alpha and beta. When working with parametric equations, we know that the arc length s is the integral from alpha to beta, the square root of dx d theta squared, plus dy d theta squared d theta. In this case, theta is the parameter. But in polar coordinate, x equals r cosine theta and y equals r sine theta. That is, x equals f of theta, cosine of theta, and y is f of theta, sine of theta, because r equals f of theta, where theta is between alpha and beta. Now, dx d theta is f prime of theta cosine of theta plus f of theta times negative sine of theta. Dx d theta is derivative of x, and dy d theta is f prime of theta sine of theta plus f of theta times cosine of theta using the product rule in both cases. Thus, dx d theta squared is f prime theta squared cosine theta squared minus 2 times f prime theta cosine theta times f theta sine theta plus f theta squared times sine squared theta. We then square dy d theta to obtain similar expressions. We then need to add the two, because in the arc length formula, we would need dx d theta squared plus dy d theta squared. But when we add these two, the middle terms cancelled out. The left-hand side is dx d theta squared plus dy d theta squared. The right-hand side is f prime of theta squared. Factor out. Inside is cosine squared theta plus sine squared theta, because we add these two. And f of theta squared, factor out. Inside is sine squared theta plus cosine squared theta. But sine squared theta plus cosine squared theta is 1. Thus, dx d theta squared plus dy d theta squared is simply f prime of theta squared plus f of theta squared. The results is summarized as follows. If the point P traces the curve r equals f of theta exactly once, at theta runs from alpha to beta, then the length of the curve that gives the distance the point travels is s equals the integral from alpha to beta, the square root of f prime of theta squared plus f of theta squared d theta. This can be written as alpha to beta as the integral, the square root of r squared plus dr d theta squared d theta.